All right, so this is 5.1, number 6. Had some questions on this one. 5.1. It says, as of the year 2017, the national debt was about $20,244,000,000,000. The population of the United States at that time was about 325,700,000. If the debt was divided evenly amongst everyone, how much would each person owe? Express your answer in scientific notation. So all we're really going to do is take the total debt and then just divide it by the number of people. So we're going to take debt over population and divide it. So the debt is 20,244,000,000,000. And we're going to divide that by the total number of people. So 325,700. And so we're really just dividing these numbers out. So again, the point of scientific notation is so that you can write really large numbers in a smaller form. So you don't have to write all the zeros out. Or write really small numbers in an easier way. So the problem is still just taking these two things and dividing them out. So, we could start here and go ahead and divide. If we just divide those raw numbers out, if you divide those numbers, you get about 62,155 and then 0.3576911. So we can go ahead and do that. And then we can take that number and put it into scientific notation. That's one way that we can do that. Since the numbers aren't super huge right here, we can just type them in. It's a reasonable thing to do it that way. But let's put this into scientific notation because that's what the problem asks for. It says put it into scientific notation. So scientific notation means the first number is going to be in between 1 and 10. So since I'm at 62,000, I have to take that decimal and move it to the left 1, 2, 3, 4 spots. So this first number would become 6.21553576911 if we kept all the digits. Now, since we moved it to the left 4 times, that's basically like dividing by 10 4 times, which is equivalent to multiplying by 10 to the negative 4th. Okay, so we have to do the opposite of that. So we're going to multiply this by 10 to the positive 4th. And this should make sense because if I multiply it by 10 to the 4th, if I went back to my raw number, every time I multiply by 10, I move the decimal to the right 1 spot. So I'm going to go 1, 2, 3, 4, and you can see that it would make sense that it's back at 62,000. And then in terms of the precision, do we need all these decimal places? We're just going to round this to 6.2155, and we'll call it good. We're not going to talk about, significant digits, but essentially, since these numbers, it looks like they were that precise. It looks like there was 5 digits that they were, we have 5 significant digits, and we kind of rounded here. We're kind of making some assumptions there. I'm just going to use, 5 digits in my answer. 6.2155 is good. We're not going to take off any points for using significant digits correctly. That's not really the point of this section. But if you want to learn more, just Google significant digits, or you might have already used it in your science classes. So here's an answer. We can write it like that. Now the answer key also kind of does this problem by putting it into scientific notation before we even do the calculations. So this is one way to do it, and it's totally fine to do it that way. But kind of the second way is to take the numbers as is and first write them into scientific notation and then do the division. So you can do it like that. Like I said before, you don't necessarily have to in this problem because the numbers aren't insanely large and you can type everything in. But it's a good practice to have to just do that scientific notation. So if we did it like that, and we took the debt, right? We would write the debt as 2.0244, right? Because that first number has to be in between 1 and 10. And then we'd have to think about, all right, well, this is times 10 to the what? How many decimal places over did I have to move that from right here at the end of this large number? How many times did I have to move that over to get to 2.02? So, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times I had to move that over. So this would be times 10 to the 13th. And so we could do it like that. So this is times 10 to the 13th. And then we can put the other number in scientific notation. So now I'm going to have 3.257 and do the same thing and say, all right, well, if I have my decimal place over here, I had to move it 1, 2, 3, 4, 5, 6. Oop, lost count. 1, 2, 3, 4, 5, 6, 7, 8. I had to move it 8 times over. So this would be 3.257 times 10 to the 8th. And then from here, since you put it into scientific notation, then we can do the division here and kind of break this apart. So I could take, all right, let me take these numbers right here. Let me take 2.0244 divided by 3.257, and I'll do that first. So you divide it up, and you would get this right here, right? Points. Again, we're getting the same thing as we got before, but it's now in decimal form. So 0.62155,357, etc. And then we can take the powers of 10 right here, and we could do that division. So then we could say, well, this is going to be times 10 to the 13 minus 8, right? So this is 10 to the 5th. And we still have the same value that we've been working with in the in the first solution of this problem. It's just we're doing it in a different way. So now we are looking at this, and we have to change this to scientific notation, because now our answer is 0.62. Well, that has to be a number in between 1 and 10. So we just have to make another adjustment. So now I'm going to say this is 6.215, etc. I'm just going to give 5 digits here, 5 significant digits. You can see the same problem here. If you look in here, there's really only as much as 5 digits of precision. So again, we're kind of sticking to that level of precision. I'm only going to have 5 digits of precision here. Okay, so I changed this to 6.2155. That means I moved the decimal to the right 1 spot. So essentially I multiplied this by 10. And so therefore I have to adjust this by dividing or subtracting one of those 10s to keep it in balance. So I'm going to take this and now make it 10 to the 4th to do that work. So there's my answer. I had a lot of questions on this one because I think looking at the answer key, this process right here was a little bit confusing. But that's really, really good practice to put things into scientific notation and then work with numbers in scientific notation. However, if you just did it the first way and just took the raw numbers and divided them and then put it into that notation, that's good too. So let me know if you have more questions on this problem, and that's it.